This is going to be a review through assertions. The main method. So parts of the code. This example here is an example of what a main method looks like. The public is a keyword meaning that everyone has access to this class. Class is a keyword denoting the class, and there's one per file for now. And a class is just what we call the implementation of a Java file. Example is the name of the class, which will have to exactly match the file name. Static is a keyword denoting the type of method, and static just means that there's one instance per class. Void is the return value for the method, and it's always void for the main method. And we'll talk about types of return methods other than void later in this review. Main is the method that runs the code, and there's one per file, and it's always called main. If you don't have a main method, then you can't run your Java file. And the string args is an array that holds the command line arguments, and we'll talk more about arrays in a later tutorial, as well as how to manipulate the command line arguments. And then this grayed out part is a comment, and a comment is just part of your code that won't actually be run. It's there for you to put extra information about what's going on with your code. So printing, there's two different print methods. There's print, there's system.out.print with what you want to print in quotes, and that will print without going to the next line. And then there's system.out.println with what you want to print in quotes, and that will print and go to the next line at the same time. And these print statements always need to be wrapped inside of a method. So the couple of escape sequences that you need to know about, there's \t, which is a tab character, \n, which is a new line character, \\, which will give you a \/ character, and you're always required two to print a single \/ character, and that's because the computer, anytime it sees a \/ it thinks you're starting an escape sequence. So in order to print a \/ you need two of them. \/ quotation will actually print out a quotation, and you need the \/ so the program doesn't think you're ending what you're trying to print. Types, variables, and expressions. There are 8 primitive types. So the types on the left, byte, short, int, and long, are all different sizes of whole numbers, and most of the time you'll just need to use int for the whole numbers. Float and double are different sizes of a floating point or non-whole number, and most of the time you'll use double for non-whole numbers. A boolean is a truth value, and its possible values are true or false. And a char, which is short for character, is a 16-bit Unicode character, like A in single quotes. And you can also set characters according to ASCII values, which are just numbers that correspond to Unicode characters. Some example assignments. So over here is assignment for whole numbers. If you're assigning a long, you need to put an L at the end of it so the computer recognizes that it's a long. And float and double are here. If you're doing a float, you need to put F at the end of it. A boolean can be either true or false. And like I said, you can set a character by the single quoted Unicode character you want, or with its corresponding ASCII value. So capital A corresponds to 65. There's operator precedence. So it goes parentheses, exponents, multiplication, modulus, and division. These 3 all have the same precedence, so you apply them left to right. And then there's addition and subtraction, which also have the same precedence, so you apply them left to right. And modulus, again, is when you take a number, divide it by the number you're modulusing it by, and the answer is the remainder of that division. So 35 mod 2 is 1, and 47 mod 5 is 2. And then you can remember that by, please excuse my marvelously deranged Aunt Sally. Static methods. So the syntax for a static method is public static void and then the method name. with code going inside of the braces for that method. And then you can call it with just method name, open and close parentheses, semicolon. And methods always have to be called inside of other methods. The steps for using methods. You design the algorithm, so you'll look at the structure and which commands are repeated, decide what the important overall tasks are, and those two things will be where you make methods: important tasks and repeated tasks. And you should do this before writing any code. If you have a hard time doing that, it's okay to write out all of your code and then split it into different parts of an algorithm if you want. So then you would write down the methods and arrange the statements into groups, which is basically just arranging statements into groups and giving each group a name. And then you would call the methods. So the program's main method executes other methods to perform overall tasks. And some methods can call other methods if they want to. Parameters and return values. Creating a method with a parameter. So it goes public, static, void, method name, and then in parentheses, the type and the parameter name. And inside you would do stuff with the parameter. So system.out.println, the parameter was, and then the parameter name. So this type can be any type, int, double, boolean, whatever you want it to be. And then these two have to match exactly, just like if you're using any other variable in your code. Calling a method with a parameter. So now you can call the method by method name and then passing it in another variable, or by passing it a value explicitly. And this variable name doesn't have to match the parameter name, it just has to match the type. You can have multiple parameters, and to do that you just separate them by commas, and you have to have a type for each parameter that you put in. And those types can be different or the same, it doesn't matter. You just have to have type, parameter name, comma, between every different parameter that you use for your method. Method overloading is when two or more methods have the same name but different parameter lists. So they either have a different number of parameters or parameters of different types. If you have a method that's the same name with the same parameters, you'll get compile errors because that's confusing for the compiler. Creating a method with a return value. So to do that, it's public, static, and then type here instead of void. So whatever type you're going to be returning, int, boolean, double, any of that, and then method name. So you can either do it by doing type x and then some code and calculation for that sets it, and then returning x, or you can just return a value that has the same type as what you're returning. And when you call a method with the return value, it looks like this: type x equals, and then you calling the method with the return value. If you don't save off the value that's returned by the method like this, it's exactly the same as if you were to do like 2 semicolon in the middle of your code. The return value wouldn't have any value to you because you're not doing anything with it. So always save off the return value like this. Strings. Actually, before I move on, it's important to remember you can mix up something with a return value that has a return value and parameters, and that's just a combination of having a return value and parameters. So here, if this one had a parameter, you would just pass in its parameters between this set of parentheses. Strings. So whenever you declare a string, it goes string and then string name equals, and then some string in quotes. And to update it, you can do s equals s plus, and then another string in quotes. And it's important to remember that strings are immutable, which means every time you change a string, you're actually creating a new one. So it's a little bit inefficient, so you need to be, if you're going to be doing a lot of string concatenation or adding to strings, just be aware that it's going to be slowing down your program. Indexes of strings. Indexes are used to keep track of the characters in a string, And strings, like most other things in programming, are zero index, which means the first character in a string is at index 0. And the last character is at index length -1. So in the case of Penguin's Rock, P is at 0 and K is at 12, and the length of Penguin's Rock is 13. Something to keep in mind whenever you're using methods like index of or char at on a string. So for string methods, a cool trick is that in IntelliJ you can get a list of string methods by doing s dot, and IntelliJ will automatically show a list of the methods that you can apply to the variable s. This list will shorten as you type in the name of the method that you actually want to use. Printf. So printf syntax is system.out.printf string for the format string, and then parameters. So this will include placeholders for width, alignment, and precision information, and it can have multiple placeholders. And parameters can be as many parameters as you have included placeholders in the format string. So this can be one to many parameters, all separated by commas. So the printf placeholders are %d for an integer, %f for a real number, which is a double, and %s for a string. So printf with width and alignment. So %wd is for an integer, that's w characters wide, that's right aligned, because the default for printf is to have things be right aligned. %-wd is an integer, that's w characters wide, that's left aligned. %.df is a real number that's rounded to d digits after the decimal. So for instance, %.2f would round any number that you give it to the hundredths place, which would give you the formatting for like a dollar amount. %w.df is a real number that's w characters wide, that's d digits after the decimal. And the width includes the digits after the decimal as well as the decimal point. And then %-w.df is a real number that's w characters wide, left aligned, with d after the decimal. Boolean logic. When you're comparing numbers, you use equals equals to see if they're equal to each other. Not equals or exclamation point equal will return true if the two numbers or expressions are not equal. And then for the rest of them, exactly what you would expect it would be. Less than or equal to, greater than or equal to. And remember, with equals, it has to be two equal signs. If you don't include both, you'll be doing assignment, which will always return true, which will mess up your program potentially. So watch out for that. Comparing objects, like strings. Objects cannot be compared in the same way that numbers are. They have to be compared using either object1.equals object2 or object1.compare to object2. If you try to compare objects using equals equals or not equals, you'll actually be comparing memory addresses of the objects, which is not what you want, usually. So you'll have to use .equals or .compare to. Expressions with multiple parts. Sometimes Boolean expressions need multiple parts, like if you want to have a Boolean for a number being negative and even, or a Boolean for a number being even, or a multiple of 5. So and, which will put between two or more Boolean expressions to require both to be true in order for the whole expression to be true. And then or, which is actually the pipe symbol, which is above the backslash on your keyboard, is put between two or more Boolean expressions to require at least one to be true in order for the whole expression to be true. So the important thing to remember about these is they're evaluated from left to right, and they only are evaluated as far as they need to be. So for instance, the and will return false as soon as something in it is false. So if the first thing is false, it won't even look at the second thing. And then or will return true as soon as something is true. So if the first thing is true, it won't even look at the second thing. But if the first thing is false, it will need to look at the second thing to confirm that it's actually, that the or is true or false. If statements. So this is the diagram for a plain if statement. It goes if test, and then statement A, and then statement B happens regardless. So it'll say, is the test true? If yes, execute statement A, and then statement B, and if it's not true, it'll just execute statement B. So A is executed conditionally on the test. For an if else, it'll say if test, do statement A, otherwise do statement B, and then statement C is done regardless. So is the test true? Yes, do statement A, and then statement C. If the test is not true, do statement B, and then do statement C. A cool trick is a tertiary if statement. Tertiary if statements are a way to set a value as if you're using an if-else statement, but they only take up one line. Here's an example. Int x equals 4, and int y equals x greater than 3, question mark 2, colon 14. The explanation is it's saying, if x is greater than 3, set y to 2, else set y to 14. And these only work if you're going to be setting a variable based on some condition. So for a nested if-else, it goes if test1, do statement A, else if test2, do statement B, else do statement C. And this set of nested if-else can have as many else-ifs as you want it to have, and the else is not required. You could just do an if and then a series of else-ifs and leave off the else if you wanted to. So it goes, is test1 true? If it is, do statement A. If it's not, test 2. If test 2 is true, do statement B. And if test 2 is also false, do statement C. And then do statement D at the end of all of it, because since it's outside of these braces. Class constants. A class constant goes at the top of your class, and it's used to get rid of magic numbers in your code. So let's say that I know I'm going to be using 4 a lot in my code, but I don't want to have just a random 4 lying around because 1, it won't make sense to whoever comes back and looks at my code later, and 2, if I have to change that 4 to something else, that 4 will be hard to change because I'll have to find it everywhere in my code and replace it in multiple spots. So instead, I create a public static final int example constant to hold 4, and now put example everywhere in my code that I would have put 4 otherwise. Switch statements. A switch statement is basically an if-else that only compares a single value. So I have switch on a variable, and I'll say case value 1, statement A, break, case value 2, statement B, break, default. So this is like saying, if variable is equal to value 1, do statement A, else if it's equal to value 2, do statement B, else do statement C. And these break statements are very important. If you don't have the break statements, it will just fall through to the next set of in the switch case, which will not be what you want most of the time because it'll execute. It could, if for instance, if this break is gone, it would execute both statement A and statement B instead of just statement A. And just like the else in a nested if statement, this default is not a requirement. It's just something that's nice to have so you know if none of your other cases have been caught. Exceptions. Exceptions are things that are thrown whenever something goes wrong in your code. And the 4 common types are a null pointer exception. An example of that being thrown would be calling .indexOf on a null string. An illegal argument exception, which is thrown by the programmer when a parameter isn't correct for some reason. An index out of bounds exception. An example of that would be calling char at 12 on a length 5 string. And an arithmetic exception, which happens when bad math occurs, so like dividing by 0. Whenever you have a try-catch, this is a way to handle an exception without having your whole code grind to a halt like it normally would. So you have try, and then some code that might throw an exception, and then you can catch a specific exception like catch null pointer exception in, which is checking for a specific exception. And then you can do in.toString, which will print both the type of exception and then a colon and the message that goes along with that null pointer exception. And then you can do a catch exception E, which will catch a general exception. So it'll catch any other exception that's not a null pointer. Throwing an exception. You would do throw, new, and then exception type, like null pointer, or illegal argument exception, and then the exception message in quotes. Assertions. An example of assertion would be assert and then Boolean statement, so the thing that you're trying to assert, colon, and then the message for the failed assertion. And this message should be something descriptive enough that whenever you catch it later, or it gets thrown onto your screen throughout the running of your code, you know exactly what's gone wrong. And don't forget, you'll need to edit the configuration to have -EA in the VM options in order for the assertions to work in IntelliJ. And on top of that, whenever an assertion is thrown, it's an error, not an exception. So you'll have to catch the assertion error as opposed to catching a generic exception like you would otherwise. And that's it. I hope that was helpful.